Love that. All right, here we go. Let's talk about fractions. Let's get the basics here. We have a fraction, A and a B. What's the A called? Numerator. Very good. Bottom, I heard somebody say. Okay. What does the B represent? Emma? Okay. It represents the whole. That is correct. How many parts it takes to make one whole? Okay, we'll put some numbers to this in a minute. Okay, once again, how many parts it takes to make a whole? One whole. What's the numerator? Numerator? Okay, Michael? Okay, so that is correct. Well, not how many parts are in the whole, but how many parts. Okay, and what that means is it depends on the problem. How many are shaded, how many you need, things like that. Okay? The numerator, the way that we would interpret it is based on the question. Okay, but the more important part is the denominator. That's definitely how many pieces we need to make a whole. So far, so good? Okay. So if we had this, how many parts would it take to make one whole in this example? Just yell it out. 4, right? So if you have a circle, the shape is immaterial. It takes 4, and shall we say 4 equal parts to make a whole. Right? And then in this example, we could say Johnny ate 1 piece of pizza. How many pieces are left? Okay. How many slices? Yeah. Okay. So that's where the numerator comes in. Obviously, Johnny ate 1 piece. We have 3/4 of the pizza left. Does that make sense? Okay. So that's how kind of the question depends on, the numerator depends on the question. So far, so good. All right. What is mixed number? First question is, what is that made up of? Bless you. Cohen, what's it made up of? I have no idea what you said. No. Save that answer for later. Thatcher. There you go. That's exactly right. Made up of a whole number and a fraction. That is correct. What does a whole number look like? Of course, you know, 2 2/3. You have a whole number and you have a fraction. So far, so good. What about one of these? Cohen. You know what this is. All right. The numerator is bigger than the denominator. That's correct. Looks something like this. Okay, so there's more parts than you have pieces. Right? So it only takes 3 to make a whole. Right? But I have 8 pieces. So I'm going to have more than 1. Correct? Improper fractions are greater than 1. They have to be. Right? Because you have more pieces than you do parts that make up a whole. Now, let's talk briefly about improper fractions. We do not write improper fractions. You might want to listen. Yes, you have to write them to solve the problems, but what do we ultimately want to do with our improper fractions? Turn them into mixed numbers. You know why? I know this might shock you here, but improper fractions do not exist outside of school buildings. They don't exist, children. I've been searching for years a profession, a job that deals with improper fractions. I can't find one. Okay? The reason is everybody out there turns them into mixed numbers, something that we can really understand. Okay? Yes, you are going to need to know how to make them and use them to get to our mixed numbers. Does that make sense? Okay. And last but not least, do you know what this is? And I'm finding out most people don't know what a proper fraction is. Dean? All right, define regular fraction. I don't know what that means in English. That is correct. It's ones that you're usually dealing with. When the numerator is smaller than the denominator. One third, 2/5, 7/8, 1/6. Anytime your numerator is smaller than your denominator, that is called a proper fraction. All right, good with the pieces and parts? Okay. Is that familiar? Okay. Let's talk about simplifying fractions. Okay, they might use those two terms, lowest terms or simplify. Again, as I've said before, you don't ever have to ask anybody if you want the fraction in lowest terms. It's assumed that you are going to put them in lowest terms. But I do want to talk about something. Okay, so let's say we have the fraction 8/12. If we divide by 2, we now get 4/6, yes? Does anybody know what kind of a fraction that is? Yes, I know it's a proper fraction, but it does have another name. Grayson? That is an equivalent fraction. That is good. That is correct. That is good, right. But that's right. That's not what we're after, though. This is called a reduced fraction. Reduced fractions are good or bad? Bad. What did we just say? We want everything in lowest terms. If we continue dividing by 2, we then finally arrive at the answer we want in simplest form, which is 2/3. Or as I like to call them, 2/3. Okay, you see the difference between the fractions, though, right? Reduced, not good. Why is it not good? Because you didn't go all the way until you can't go no more. You have to reduce the lowest terms, okay, or simplify. Everybody good with that? Okay, because again, that's going to be a common boo-boo when it comes to the quizzes and tests. Okay, everybody good with those? All right, now to the lesson. We're going to talk about fractions and estimation. All right, here we go. What is the difference between estimation and rounding? There's a difference between the two. Michael, talk to me. Okay, that's not bad. That's not bad. That's pretty good. Estimation. Okay, we can say that it's guessing. Okay, that's not bad. It's not a complete guess, but guessing is not bad. Get close. Right? Rounding. You are changing the number to a specific place value. Okay, rounding, they will tell you round to the nearest whole number. Round to the nearest tenth. Round to the nearest thousandth. Okay, if that's the case, then you will all have the same answer. right? Because they're telling you a specific place value. If they just ask for estimation, and this is, estimation is kind of a gray area, some of you will not have the same answer, but still be correct. For example, okay, we're not talking about fractions now, but if I would say 35, and I would just say, what is that closest to? Estimate 35. What are you going to give me? 40. What else are you going to give me? What are you going to give me? No, not 0. I'm not going to 35 all the way down to 0. Michael, who is it? Yeah, I would say one of those two answers. Right? Half of you might put 40, half of you might put 30, and you're all correct. See what I'm saying? Now, if I would say round 35 to the nearest whole number, what answer do you have to give me? You got to give me 40. See the difference? Right? Depending on the number, I would agree with you, yes. And we're going to talk about that today. Yeah, correct. I just tried to give one that's in the middle so you could see half of you might pick 30, half of you might pick 40. All right, everybody good? All right, here we go. Okay, so we are going to estimate, okay, and these are going to be fractions. We are going to estimate to the nearest 0, half, or whole number. Okay, now we're specifically talking about fractions. Okay, so here's what a question may look like. 3/8 times 11/12. Now you got to keep in mind we are estimating. Nobody's asking you to find the exact answer. Okay, and again, this is where you got to kind of know your facts or what the case may be. 3/8, is that closer to 0, a half, or 1? Okay, hon. That is closer to a half. That is correct. Okay, how do I know that? Well, if I take 8, because that's how many whole pieces are in that make up a whole, right? If I take half of that, that's 4, right? Is 3 close to 4? Yeah, so that's closer to a half. 11/12, is that closer to 0, a half, or 1? Tyler, what is it? 1, that is correct. So here's the problem that you're working on. This is what you're doing. What's a half times 1? It is a half. So your answer here is a half. This is what we're after today. Right there, surrounded in the pink, dotted line. You're estimating the fractions. Does that make sense? Emma? What's 1 times anything? This is, okay, that's all right. Multiplication property of 1, right? Lesson 1-3. See? Now, I'm going to keep bringing this up throughout the year. Things that you've already been taught, you can't forget. That's lesson 1-3 right there. Now we're just, instead of whole numbers, we're using fractions. All right, next one. Again, we're estimating to the nearest 0, half, or 1. 4/5. What's that closer to? 1. Correct. What about 1/6? 0. Tough one. What's 1 times 0? That was hard. There you go. That's what we're after today. Everybody good with the fractions? I know it's tough stuff. Okay, moving on. What if we have this? Okay, now when we start getting into mixed numbers, we're not estimating to the nearest 0, a half, or 1. You can't, because we have something bigger than 1, right? So now it's to the nearest whole number. Okay, what's 5 and 1/4 closest to? 5, right? When you get a mixed number, children, you look at the whole number, right? It's got to be, you go one less. Is it between 4 or 5? Or closest to, I should say, not between, right? Is this closer to 3 or 4? 4. Answer is 20. That is what we're after. So far, so good. Okay. What about this? What's different about that one than the others? This is where you got to pay attention, because some of you made these boo-boos on the quiz. Emma? Yeah, you got to look at the signs, children. Some of you are putting plus signs when it's negative and negative signs when it's a plus sign. The operational symbols matter. You have to take a look at them. Closer to 11 or 12 here. 12 divided by closer to 2 or 3. 3, 12 divided by 3. Again, I know these are easy. They're meant to be easy. Okay, but if you understand the concept, right, of what we're doing, it doesn't matter what kind of numbers we give you, you should be able to do them. Now, the one thing that I will say, don't lose track of the order of operations. Remember, if there's multiple things, you have to follow the order of operations. Please excuse my dear Aunt Sally, right? So far, so good. Okay. Let's talk about these. This is probably new to you. Compatible numbers. Definitely want to write this down. These will be on your quiz. And this is going to be to Ryan's point that he brought up here. Compatible numbers. I'll give you the definition. Numbers that are easy to compute mentally, i.e., make the numbers easy for you to be able to do the math. That's all that means. Okay? Now, listen carefully. This is not estimation. This is not rounding. This is changing the numbers so you can do easily in your head. Now, do you have to do them in your head? No, you don't have to. Okay, if you want to do some side math, that's fine, but that's not the idea. The idea is you can do them easily in your head. For example, and again, this is where you have to know your math facts. Your life becomes so much easier if you know your math facts. 61. 61 divided by 4 3/8. Now, we're not dividing that. That's crazy talk. Okay, but what do you want to change so you can easily do these in your head? Ryan, what are we going to change 61 to? Yes, I would agree. Okay, we can change the 4 into 5. How many 5s go into 60? 12. Very good. Now let me ask you this. Can you do this? Will that work? Will either one of these work? Yes, and you're both correct. Do you see how they're compatible? Somebody might think of it as 60 divided by 4, you get 15. Fine. Somebody might say 60 divided by 5 because I know that those facts better. It gives me 12. That's fine. Okay, there's not a perfect answer here, but there is wrong answers. Okay, there are wrong answers. You want to change it close to the number that is given for you. Does that make sense? Like you won't want to go, okay, I'm going to make 6150. No, that's too far away. Right? That makes sense, right? That's way too far away. You want to make it relatively close to the number they give you. That's the idea. Okay? How about this? How about this one? You got to kind of be careful with these. Okay, what do we want to do to 151? 150, right. Remember, relatively close to the number. Now, I can see where this is going to go maybe wrong. 2/5. Think about that. Okay, 1. Anybody know what 2/5 look like as a decimal or a percent? Anybody know? 40%. What's 40% closer to? 0, a half, or 1? Closer to a half. Okay. So that answer is going to be 75. Again, you want to stay close to what you're talking about, right? So if you said 1, then you're going to get 150. 75, are those close to one another? Nah, I don't think so. You're way off by 75. See what I'm getting at? You got to stay close to the number that they originally give you. And please, I mean, some people might pick 0 here. So 151 times 2/5 is 0. Now you're 150 off or 75 off. See what I'm saying? See what I'm getting at? Okay. Relatively close to the number that they give you. Any questions? Any questions yet? Okay, last thing. Let's talk about an underestimate and an overestimate. One of these is easier than the other one. Okay, so we know what an estimate is, right? Get close. Correct? You don't have to find the exact answer. We don't want you to find the exact answer when we talk about an estimate. Okay? Now, here's the thing in life, you're going to use this skill more than finding the exact answer. In life, you just want to come close. Okay? All right. Can somebody give me an example of when you might overestimate something? Anything in life. Michael. Okay, when you're buying something. Okay. Perfect. Right? When you go grocery shopping, when you go school shopping, when you go shopping in general, don't you want to have more money, correct, than what you may purchase, so you have enough money to buy? Okay, those are the easy ones, right? Another easy one is when you go on vacation with your family. Mom and dad take money, right? They probably want to take a little bit more than, because they don't know what they're going to spend money on, right? So you want to overestimate. Okay, that's the easy one. The harder one is underestimate. Think about that for a minute. When do you think you might want to underestimate something? Michael? Well, no. You always take more. Here, it's hard. Underestimating is hard. But you all might understand this one. How about microwaving popcorn? What happens if you overestimate the time? It burns. Okay, so this was a good one we came up through the years. Microwave popcorn, right? If it says a minute and a half, you might want to put it on a minute and 15 seconds, a minute and 20, right?
I put it on 2 minutes and then I wait for the
Children, if I'd love to hear you, just raise your hand. We all can't talk at once. Okay, that's something that you might want to underestimate. Okay, maybe driving in a car with gas and mileage so you don't run out of gas, right? If it says in the manual that the car can go 400 miles, you might want to stop and get gas between 300 and 350 so you don't run out of gas. You underestimate. Does that make sense? Okay, those are the harder ones. Okay, so that being said, what happens if the problem looks like this? Okay, and we'll just say we're going to paint the ceiling. That's a ceiling. I don't know. Making something. Oops. We're going to paint the ceiling. Are you going to over or underestimate? Yes, you want to overestimate because you want to make sure that you buy enough paint to cover the ceiling, right? You certainly don't want to be painting the ceiling and run out of paint. That wouldn't be good, right? So if we are overestimating, what are we going to change 27 and 5/6 to? Okay, yes. I wouldn't say 28, right? You could, but I'd make your life easier and say, hey, I'm going to change this to 30. Right? And we can do what to 10 and 1/4? We can do 10, right? So now we need 300, whatever we're talking. Okay, yeah, 300 square feet of ceiling. So now I can go to the store and buy something that has 300 or more square feet. Does that make sense? Okay, any questions on fractions or estimating? All right, here's what we're going to do next. Listen, this is changing for you. Okay, your homework now is in the book pages. Listen carefully. Okay, I gave you the book pages. Okay, that is something that you're familiar with, but now all of our problems are coming out of the book pages. Okay, please pay attention. You are going to do 7 through 39. You are doing the odds. You are only doing the odds. Now, listen to me. I also have provided you, okay, because I need to do this for the people that are at home. If you checked on the course, what else did I provide you there? The answers, which scares me, I'll be honest with you, but listen, you can turn to the answer section and copy down all the answers and be, yay, I'm done with it in 5 minutes. Did you learn anything? It goes back to our conversation at the beginning of class, right? Yeah, you're done with your homework, mom and dad. I'm done. I don't have to do anything, but you don't understand what you did. That's a problem when it comes to the quizzes and tests that we're experiencing. Okay, so I've given you the answers. You can check to see if you're right or wrong. That's a good thing. Okay, but understanding how to do it is more important. Okay, so when you come in, I'm going to check your homework that you did it. Okay, but you're going to be expected to also check it so we can move on and do more things, more problems. Does that make sense? Everybody good? Everybody know what's expected? All right. You may begin.